if I can get that. Let's try to find. Okay. And we have someone that joined. Welcome, Gary. That did not copy the way that I thought it was going to copy. So Gary, I am about to do some word problems from, that copied more than I wanted to copy. Let's try this. There we go. Okay, so I'm going to do some word problems from section 1.3 from last week. And if you have something that you want to see, you can like type that into the chat box while I'm going through a word problem. So here I picked this as involving percents. So percents actually come up a lot. This is very helpful in real life, so that's why I picked this problem. So Belle had the choice of taking out a 4-year car loan at 8.5% simple interest, or a 5-year car loan at 7.75% simple interest. If she borrows $15,000, how much interest would she pay for each loan, and which option will require less interest? That's the one that's in your best interest, is to have less interest. So simple interest, as soon as you see simple interest, that is actually a specific formula that you want to know. Hi, yeah, Gary, do you have a question?
Yeah, Stephanie, later on, after you're done with the live chat session, I'm having some troubles with the graphing aspect on my computer. When I try to do the graph on the number line, part of it will turn blue, the other part will stay yellow. I cannot get it through Alex, and I am very frustrated because I should have been done with homework and everything a week ago, and I just can't get it to turn blue.
Okay, sure, we can look at that after this. Okay, so going back to the 1.3 here and the simple interest formula. So the simple interest formula is basically, it gives you interest. So it says that your interest is equal to the principal, that's how much you're investing, times your rate, so that's the percentage rate, and then times time. So the rate is always as a decimal. So a lot of people miss that you have to convert that percent to a decimal. So this question is asking how much interest you would pay. So this is the formula you want to use, because this formula will give you interest. So we're going to calculate this for both loans, the 4-year and the 5-year, to see which is the better deal. So we've got the 4-year and then the 5-year. So the 4-year car loan is at 8.5% interest. So that has to be converted to a decimal, and we do that by basically moving the decimal point to the left 2 places, or you can divide it by 100. So if you divide 8.5 by 100, you get 0.085. So that's what you're going to use for R. So our formula I equals P. P is the principal, that's how much you're investing, or in this case, borrowing. So that's going to be $15,000 times our rate of 0.085. And then this is a 4-year loan, so you're going to be multiplying it by 4. So simple interest always assumes that it's yearly interest. So it's just the number of years. So once you set that up, then you just put it in your calculator. You're just multiplying all of those numbers together. And you get 5,100. So $5,100 is the interest on that loan. Just the interest. So that would be added on to the $15,000 you already paid. You'd be paying over $20,000 for that loan. Now, the 5-year is 7.75%. So going to be the same sort of thing. And I know, Bonnie, I make it look easy. With practice, it is. It can be easy. Everybody can do this. I think it's just a matter of getting the right video, seeing it worked out step by step. It's not scary. My favorite thing is when I have students that say, I used to hate math and now I'm actually having fun. I love it. So the 7.75%, we want to divide that by 100 to make that a decimal. So that's going to be 0.0775. Yes, Gary, I see you raise your hand again. Do you have another question? I am not hearing you if you are speaking. Okay, well, I will continue then. So our 5-year loan has 7.75%. I'm going to use the same formula. We are investing the same amount of money. It's just a question of which loan is better. So now my rate is going to be 0.0775. And then this is going to be 5 years instead of 4. So then you just pull out your calculator. And that gives me $5,812.50. So believe it or not, the better loan is the 4-year loan with the higher interest rate because you actually have a smaller number for interest. $5,100 is much smaller than $5,812.50. So this is why it's important to do the math, because if you actually are, shopping for a loan or something like that, you might say, oh, 7.75%, that's better, but you have to look at how long the loan's going. And you're right, this is exactly how they get you. And this is why it is important to understand algebra, because then you can double check these things. Now this is just a simple interest formula. Real life uses compound interest, but that's something that you can even do on an Excel spreadsheet to calculate it out for yourself. And then there's other things they take into account, like this is assuming you're making no payments during those many years. So they get a little more complicated, but you can find spreadsheets to check all this out. But this is basic, just checking the interest, using the formula, what saves me money. So that is an interest problem. Let's see. I'm going to do a mixture problem because that could really confuses a lot of people up. So and this is like one that's relevant if anybody's going into healthcare. So this is a mixture problem. How much 8% saline solution should Kent mix with 80 cc's, cubic centimeters, of an 18% saline solution to produce a 12% saline solution? So because you're mixing things together, this is what's called a mixture problem. And this is something that in healthcare, so let's say you ran out of some percent of saline that you needed, you have to figure out, oh man, I have to make this percent. You have certain things to work with. You have to figure out, okay, how much do I need to do this? So mixture problems have a general setup, and there's a table that they use, which I think is very, very helpful. So you basically have your first mixture, the second mixture, and then, or I shouldn't call these mixtures because they're not mixed yet. Solution 1, solution 2, and then the mixture. And we have a formula that is your amount, or the volume, basically how many liters or gallons or whatever you're mixing together, times the percent, and then it's going to give you total. So fill in this table. And the way that this table works is that you multiply your volume by the percent, and that equals the total. So you multiply the first columns to get the third column. And then when you're working down, the volumes add to equal the mixture, and the total adds to equal the mixture. Percents don't add, so you can't do that, but for the first column and the second column, you add when you're going down. So you set up this table, and then you start filling in the information that you know. So we've got an 8% saline solution, so I'm going to put that in the percent. So this is going to be the 8% solution. And then we've got an 18% solution. So I'm going to put that here. And we want a 12% solution. Now I could convert these percents to decimals, but in a problem like this with the mixtures, we don't have to. We can leave them as whole numbers. So now I need to fill in my volume, the first column, with the amount. So it says how much 8%. So that means we don't know how much we need. So that's going to be our variable x. So we don't know how much we need of the 8%. That's our unknown. And Kent is mixing this with 80 cc's of the 18%. So the amount of the 18% is, 80 cc's. And now we filled in all the numbers we've got. So those are all the numbers we've given, and we've got these empty boxes. Well, we use the table to fill these in. So on the amount column, we have that plus sign and it equals the bottom. X plus 80 equals, and so we write that x plus 80. So you're literally just adding those, and that's what fills in the bottom box. Now we've got our third column, and we're moving from left to right. We've got the volume, or the amount, times the percent. So you're going to be multiplying going across. So each of these, I'm using a star so it doesn't look like the x. I'm going to multiply going across. So I have x times 8, which is 8x. Then I have 80 times 18, which I'm going to pull out my calculator for. $1,440, and then I have x times, or x plus 80 times 12. Now this one I'm going to write with parentheses because we're going to have to distribute, and it's very easy to make a mistake there, so I'm going to just not multiply that one out right away, and I'm going to write it in the form with the parentheses. So once you've filled in that table, then you take your last column, and that's what gives us our equation. We have the 8x plus 1440 equals 12 times x plus 80. So you're just adding the top two boxes, and they equal the bottom box. And then you're solving for x. So the first thing is to distribute. So I have to do 12 times x, and then 12 times 80. Which calculator tells me is 960. So I've got 8x plus 1440 equals 12x plus 960. So now we want to get all the x on one side, and it doesn't matter which side you pick. I just always like to put it on the left. So I'm going to subtract my 12x. Since it's positive, we do the opposite, so we're going to subtract. So 8 minus 12 is negative 4. So I have a negative 4x plus 1440 equals 960. So now I need to get the 1440 to the other side. So that's positive, so we're going to subtract. We're going to subtract 1440. So that gives me a negative 4x equals, pull out my calculator, 960 minus 1440, I got negative 480. So now I want x, I don't want negative 4x. So I need to get rid of the negative 4, that's multiplied, so we divide. So we're going to divide both sides by negative 4, and you include that negative sign there, because we want to have a positive. So negative 4 divided by negative 4 is 1, so that just cancels out. So I just have x. And then I take the negative 480 and divide it by negative 4, and we get 120. So that's what x is, and we want to make sure that we're answering the question. It says, how much 8% solution should Kent mix to produce this thing? So you should mix 120, we want to have our units, cc's, of the 8% saline solution. So you want to make sure that you're answering, and we know that we set x, our unknown, as the 8%, so that's exactly what we're looking for. So you need 120 cc's of the 8%. You already have the 80 cc's of the 18%. And then those add up to 200 cc's total is what your final mixture is going to be. Are there any questions? Yes, Gary.
Okay, on story problems, I'm just curious if you could give us a couple hints in how not to get caught up in the fluff. You know? Because I get lost.
Focus on the numbers, and you also want to focus on the type of problem, because there are basically, in like 1.3, they give you like 4 or 5 different types of problems. So
That's what I'm talking about.
Yeah. So you need to identify which type of problem you have, so that way you know what you need to focus on. So if it's involving percents, then that's going to be one type of problem, and that's like percent, like usually with money. This involved percent, but you started mixing things, so that's going to be considered the mixture problem. Anything that's involving distance and speed is a uniform motion problem.
Okay.
There are types of problems where they usually ask you for the total of something, like how many of this plus how many of this, or how many did each person get, where you've got like 2 things going on. That's another type of problem. So you want to be able to put these into buckets, into categories, say this is this type of problem, because then you know what setup you need and what you need to pay attention to. And that will help you narrow it down. Like you identify this as a mixture problem, so you know you need to make this table. And then that helps you fill in what you need. Or if it's involving interest, you know that you have an interest formula, and then you pick out what you need for that formula.
Okay. The reason I'm asking this question is because even in the greater and less than, they give you story problems, and I just get lost on those. If 8 times is greater than 140, what is, the graph look like?
See you, Bonnie. Take care of your dogs. You may have heard my dog barking earlier. Yeah. So those type of problems, when you have those type of problems where it's like, if this is this much more than this, those are direct translation problems, where you're going to take each sentence and translate it into an equation or an expression. So those are where you want to have a list of words and what they translate to. Like if you know it's inequality, you're going to have a greater than or less than symbol. You know, what words translate as multiplication versus subtraction or addition.
Okay.
And those generally can get translated left to right, just like the way we read. There are a few exceptions, usually with the division and the subtraction. Sometimes those get translated in the opposite order. But if you translate those left to right, and you basically can do like a word for word back and forth to translate it, and then that will give you your equation that then you can solve.
Okay. All right. I'm going to go ahead and mute myself so you can continue.
Well, Bonnie had to leave, so I'm going to turn off the recording